using types and variables. So types will be covered in more detail in the next lectures, but it's useful to give a basic information here. So C++ is a strong type language, as we mentioned earlier. So which means that you have to declare the type of the variable that you use. So the reason for this is that the compiler needs to know how much memory to allocate for the variable, and it can determine this by the type of the variable. So in addition to the compiler needs to know how to initialize a variable, if it has not been explicitly initialized, and to perform this initialization, the compiler needs to know the type of the variable. So the C++11 provides with the auto keyword, which you will learn, so which relaxes this concept of strong typing, and it will be covered in the next chapters. So however, the type checking for the compiler is so important that you should use type checking as much as possible. So C++ variables can be declared anywhere in your code as long as they are declared before they are used. So where you declare a variable determines how you use it. So this is called the scope of variable. So in general, it is best to declare the variable as close as possible to where you will use it, and within the most restrictive scope. This prevents name clashes where you will have to add additional information to disambiguate two or more variables. So you may and should give your variables descriptive names. So this makes your code much more readable and easier to understand. So C++ must start with the alphabetic character or an underscore. So you can start, so for example, C++ have to start with alphabetic character or an underscore. So you can write variables like this in, for example, integer my variable, and here as you can see there is no error at all, and you can write your variables by to upper score variable my variable to you can underscore my variable 2 and integer my variable 2 here. So as you can see here, these names are almost same, except there's an underscore here, but these three names are same. But as you can see, we didn't get an error. If you write this exactly like this, underscores and upper scores like this, for example, you will get an error because of this redefinition. So we have to remove the previous declaration of a local variable as C++ suggests. So let's compile it and see what happens. So redeclaration of an integer variable. Not here, integer variable previously declared here. When we click on this, here as you can see, we can not declare the same names, but if we change this here, this alphabet here, with make it underscore, they are no longer the same variable here. As let's try it. So here. And the C++ names are case sensitive, as I said earlier, and the first two 2048 characters are significant. So you can start variable name with an underscore, but you cannot use two underscores here, as you can see here. Variable here. So nor you can use an underscore followed by a capital letter here. As you can see, local variable is only assigned but never accessed. Here we got no error here. So, and clearly you cannot use type name as variable names, neither built-in type names, for example, integer. So we can't use the long as a variable name because it's a keyword, and it's reserved keywords. So, or we cannot use while or other keywords in our language here, as you can see here. So you declare a variable in a statement, ending with a semicolon here, as you can see here. So the basic syntax of declaring a variable is that you specify the type, then the name, and optionally any initialization variable here. This is a type, name, and initialization variable. So built-in types must be initialized before you use them, as you can see here. Integer e here, let's increment e by 1, and here std cout and e here. And let's make a return statement here, and let's run this program here. As you can see, we got an error. We got not error. This is a correct program. This program compiled successfully, and as you can see here, there is a output 1. So this gave us output 1. This is the 0 by default, as you know earlier, and we increment by 1 here, as you can see here, and so 0 plus 1 equals 1, and we got this 1 here. So there are essentially 3 ways to initialize variables. You can assign a value, you can call the type constructor, or you can initialize a variable using function syntax. By the way, you will learn constructors for classes in next lectures. So let's create some program here, some syntax here, the code here. A equals 1, assign it 1, integer b, integer 2, and integer c here 3. So now I want to explain what these are. So obviously they are almost we can compile our program without a problem, and actually a equals to 1, b equals to 2, and c equals to 3. I will show you what these are here. A, so firstly a, then b, okay, then C, and yeah, that's it. And new line here. So let's A, B, C, and let's compile our program. Oops. Yeah. Let's delete this. C, A, B, C here. As you can see here, we got this. And there are 3 legal C++, but statistically, the first is the better because it is more obvious. So the variable is an integer. It's called A, and it's assigned to value 1. The third look confusing, as you can see here. It looks like the declaration of function when it is actually declaring variable. The next lecture will have show a variation of assigning a value using the initialization list syntax. So there is the reason why you will want to do this will be you will learn that in the next sections. So and also you will learn classes. We'll cover classes, your own custom types. So a custom type may be defined to have a default value, which means that you may decide not to initialize a variable of a custom type before using it. So however, this will result in a poorer performance because the compiler will initialize the variable with a default value, and subsequently your code will assign a value, so resulting in a assign being performed twice here. So let's print this with here. Let's print this. So let's print this with cout function here. Cout std cout here, and c here. Oops. As you can see here, If you delete this, see, as you can see, we got an error. Format specifier wchar the argument has a type init. Here, as you can see here, our program is uh, fixed here, and let's delete this also here. Actually, no, here. As you can see, we got an error. So I want to say why we got this herd and this strange number. It's because of we need to, as you can see, there's a C here. Let's delete this, and you will see our program has fixed. The error here, we used C format specifier. So if you put this operator before in printf function before any uh, alphabet here, you this C will turn into just some format specifier here. That's because you have to do the space here, and our code will fix here, as you can see here. Let's run it again, and as you can see, we got an a 1 2 3 and there's a three assignment ways in C++. So I'm waiting you in next lecture.